In this video, we will be discussing deleting a specified node in a singly linked list. So you have been given a singly linked list with a bunch of nodes, say n nodes. Then you are supposed to delete a specified node. How you specify? You specify the data field of a node, data of a node, that we call it as a key. So what is the algorithm for that? We'll discuss. Algorithm we'll discuss. Then we'll discuss the time complexity, and at the end we'll see how to run it. We'll run the program on machine, and then finally some assignment is there for you guys. So be there till the end to know everything. So let's begin with the algorithm. So you are deleting a specified node. So the first thing is you have to search the given node. That is what we call it as a locate a node, or we can call it as a key node. Locate it. Then after locating, what you are supposed to do, you have to shuffle the links. Shuffle the link. Which are the links that we'll see. Then delete that node. Delete that key node. So let's say now here you have been given the key as 1. Then you are supposed to remove this node. This is the node you will going to remove. So if you are going to remove this node, then what happens here? You are standing here. You are located means what? You are standing here. Let's say that is the temp. Temp is address of the node to be deleted, and this is how we have located. We'll see the algorithm, complete algorithm. Let's say now we got it. That is the temp. Then what you are supposed to do actually, you are supposed to shuffle this link. You have to modify this link. But this address is not available to you. So how? Because you have already come to the node to be deleted. You cannot go back. There is no way out because it is a singly linked list. So while traversing, while searching, you need to keep track of a previous node also. Say before you jump to the next node, that current node you collect or save it as a previous node. Say now this is a previous. This address of this node is in previous. Then what you do, shuffling will be what? Previous node's link you are supposed to modify. This link you are supposed to modify. So where what it should be? It should be the temp link, because this node's address, this will be the, after this, when this node goes, when this node is deleted, this node will going to become the next node of this 3000 node, previous node. So previous link will be temp link. So this is how the shuffling will be done. Previous link will be your temp link. That's all you are supposed to do. This is the only thing. So once you modify this as, say, that is as 5000, so this way the link will be established, and now you can delete the key node. So you can say delete temp. So this is how the node is deleted. But some special cases, like if it happens to be the very first node, if the key node happens to be the very first node, in that case what happens, when this node goes, this address, the head node's link, this is a head node, starting node, its link will become new head. So that you are supposed to take care. That we'll see in the algorithm. Let's write now algorithm here. Say already this you are supposed to be familiar with creating a list. I have already given a video on this. The link I will be giving in the description box. You can just check out. So say we have created a list. The list is with us, and we have defined a class for it, because we are approaching, we have a object oriented approach for it. So now let me directly define the function like this. Say you are not returning anything here. Void, the class name is a list and the function name is delete specified. And what is the node you are deleting, you can ask the user inside itself, or you can pass also. Both cases are possible. And now let's take the pointers node star temp for temporary node and the previous node for one for previous node. So this way 2 pointers are enough for us. Locate the node. So to locate the node, you have to start the journey from the beginning. So the beginning is there in our root. Root is implicitly available to us. Then start while locating, searching while temp not equal to null. Till you don't exhaust the list, you are supposed to search. Till you don't exhaust, you have to search. And how you will search? If temp is not equal to null and if temp data not equal to key, then only you have to move ahead. If it is a match, if there is a match, means it is found. So temp represents the node to be deleted. What you need to do while traversing, you need to keep track of your previous node also. So the current temp will become previous and the new temp will be temp's link. This is what we do now here. We keep track of previous. Now there are 2 chances of coming here. You are coming at this point due to failure of this or due to failure of this. If due to this failure means what? Null not equal to null, it is false. If temp has reached to null, it means that you have not found the specified node. The specified node is not there in the list. That is the meaning. If due to this you have come out, that time what does it mean? The specified node is found. So what you can have a check here, if temp equals null, you can display a suitable message, the specified node is not found, and you can simply return. You will not do anything. So if this condition is false, it means because of this you have come out, you need to shuffle the links. But before that, we'll check the special case. If it happens, if temp happens to be head, sometime the key node, the node, say you want to delete a data with 5. Now in this case, what is happening here? The first node, the head node itself is the node to be deleted. In that case, your head gets modified. That's why this one you have to specially deal. How you will be dealing that? Your head link, new head will be what? New head will be head link. Whatever head link, this 2000 will become a new node here. That's why you have to say, and then simply delete temp. Temp is pointing to this 1000. You can delete this 1000. This is the special case. In case if this is not the case, else what you can do? Else it means what? Somewhere it is in between. If it is in between, we have seen we need to only modify the previous link. Previous link will be temp link, and then you delete the temporary, delete temp. This way the algorithm works. Let's see. We first will run it, and then again we'll come back and we'll have a dry run. And let's run the program. This is a program we have. Say already we have created a list here. The list is being created. The class is defined. Just you go through it. I'll scroll down. So this is the list. We have create will be there. Create will be there. That creates a linked list. So this already I have discussed in one of the video. You can just check. I'll be giving the link in description box. So this is the code I am interested, deleting a specified node. You can see here, I'll be starting the traversing with the head node, locate the head node, temp not equal to null and temp data not equal to key, and I'll be keeping track of previous node and going to the next node, temp is equal to temp link. And I am checking if temp happens to be null, what? Specified node is not in the list, and you will go back. If this is false, if temp equals null false, it means the specified node is found. then I have two cases. One, it may be the very first node, or it may be somewhere in between node. If it happens to be the very first node, how I check? If temp equals head, it means it is the very first node. The node to be deleted is very first node. So what you do here now, you will modify the head. New head will be head link. That I have shown you in the previous this one. Then you will simply say delete. In case if this is not the very first node, if it is somewhere it is in between, then you need to go for previous link will be temp link and delete temp. That's all. This is the thing. Let me run and show you. Say I have some nodes. I'll create a list here for 5 nodes. I am creating a list by adding nodes at the front. So my first node will be 55 and the last node will be 11, this way. Then the node to be deleted is say 22, somewhere in between. See, that node is gone. And 33, the next of 33 is coming as 11, because we have said previous link will be temp link. This is how it is working finally. Now let us try for the second case. If it happens to be the very first node, again let's create some nodes, and this time we'll give the very first node as a deleted node to be deleted, say 55. Then see, 44 is acting as the head node, because that way we have modified. This is how the delete a specified node link works. Let me now discuss about the time complexity. What is the time complexity of this algorithm? The best case is what? The best case is if the key node to be deleted, happens to be happens to be the very first node. If it is the first node, that is the best case. That time it is a constant big O of 1. So there is no need of traversing. Worst case is what? If it is somewhere in between, or if it is the last node. If it is the last node, we need to traverse all the nodes, and this is how the time complexity would be big O of n. Now there was one GATE question, somewhere a GATE 2014 or 15, I don't remember. There was a question like there is a linked list say P is the head node, address of the first node, linked list P, and it has n nodes are there. Now Q is a pointer, or address of node X. Some node is there, it is the address of that node X. Address of node X is Q, and these things are given. And say if I want to delete node X with the best known delete algorithm, then what is the worst case time complexity of this algorithm? So once again I'll repeat the question. There is a linked list P, that is the start address is P, and there is another address or pointer Q that points to node X, some node somewhere in between. It is an intermediate node. In between. So now if I ask you delete node X with the best known delete algorithm, then what is the worst case time complexity of this algorithm? So you can pause and think and try to answer. So the answer is big O of 1. Why? It is worst case they have said, but they have given directly address of node X to us, and they are asking to remove node X. Then we don't need to traverse at all. Simply what we can do, we can land in the node X, we can go directly to the node X, because no need of traversing. Then what you are supposed to do, simply remove it. So it means here one thing is implicit, that when you have been given Q, you have also been given address of previous node. It is assumed. With that case, it is big O of 1. So there is no need of traversing. When there is no need of traversing, directly you are going, it is big O of 1. So now take one assignment based on the same. Develop an algorithm or function to delete all occurrences of a given node. So in a linked list, if you have been given some nodes, say this is a list we have, and the data is like this: 5, 8, 9, 1, 8. So this way the data is there. Now if I want to remove 8, all occurrences of 8 I should remove. Now right now my algorithm what is doing, when it finds match with this one, it stops and deletes this one. But I want you to write an algorithm which will going to delete all such occurrences till the end. So just try it, and if you find any difficulty, let me know in comment box. Hope you enjoyed the session. Thank you. Thanks a lot for watching. If you really enjoyed, share it with your friends. Thank you.